Okay, so today we will discuss about the universal soil loss equation. This is the equation which are used to compute the soil loss from any field. Okay. And in the short form, this equation is known as Pusley equation. This is a very famous equation which are used to compute the soil loss from an area. So at the end of this lecture, you will be able to know about what is the Usle and what are its benefits and what are the different application of Usle and what are the modification in Usle has been done for improvement and to increase the efficiency of this equation. So this Usle equation was developed by Wishmeyer. Okay, so in 1959, this Wissmeyer had developed this equation and presented this universal soil loss equation. This equation is given by the term A is equal to RKLSCP. Okay, so these are the parameters of RKLSCP. So with the help of this equation, the soil loss is computed over an area. Okay, so what are the parameters in this equation are first A. A is average soil loss for the given period. Okay, whereas R is rainfall erosivity index. Okay, K is soil erodibility factor. So these are the some important terms. So you should remember this one. R, K, L is the length of slope factor. S is stiffness of slope factor. C is cropping management factor. And P is conservation practice factor. Okay. So these are the some terms which is related with this soil loss equation. Okay. RKLSCP. Now we will discuss all these terms one by one. So first is average A, average soil loss. So this average soil loss is expressed in tons per hectare. Okay, in 1 hectare, how much ton soil is eroded? That is A. So this the value of A is computed for any period and also on probability basis. For example, once in 2 years, once in 5 years, etc. Okay. Using the rainfall erosivity index R for the corresponding period. The second term is rainfall erosivity index and it is denoted by the R. So what is the meaning of erosivity? There are two terms. One is the erosivity and other one is erodibility. So these two terms are related with the soil loss. Okay. So erosivity means this is the ability of the rainfall to cause erosion. Okay, suppose there is an area on which the rainfall is occurring. Okay, so due to that rainfall, if the power of rainfall is more, then more soil erosion will eroded, soil erosion will take place. Okay, so soil erosion is also related with the power of the rainfall. If the power of rainfall is more, then there will be more chance to erode the soil from any place. Okay, so this power of rainfall is known as erosivity. Okay, and in other terms, you can say that erosivity is the potential ability of rainfall to cause erosion. Now the question is that how you can calculate the erosivity for any rainfall. Okay, so erosivity you can calculate. This is nothing but erosivity is nothing but this is a product of kinetic energy of the rainfall and the maximum 30-minute intensity. Any 30 minutes from the beginning of rainfall to the end of rainfall. Any 30-minute duration, the that intensity, rainfall intensity, which is maximum. Okay, that is taken, and if you multiply the kinetic energy of rainfall and 30-minute intensity of rainfall, maximum 30-minute intensity, not minimum, not normal, maximum 30-minute intensity, rainfall intensity. So if you multiply these two things, then you will get the rainfall erosivity index. Okay. So this is the rainfall erosivity index R. Now next is soil erodibility factor. Okay. So erodibility. This erodibility is related with soil. Erosivity is related with rainfall, but erodibility is related with soil. So, so there are many types of soil are there, like sandy soil, clay soil, um, silty soil, etc. Okay, there are many types of soils are there. So each soil has its own erodibility. Okay, so erodibility means this is the vulnerability or susceptibility of the soil to be eroded. Okay. So this factor, soil erodibility factor, is expressed as tons of soil loss per hectare per unit of rainfall erosion index for a slope of a specified dimension. Okay, so this factor is expressed as tons of soil loss per hectare per unit of rainfall erosion index for a slope of a specified dimension, that is 9% and 22%, 22-meter long, okay, under cultivated, continuous cultivated, follow without the influence of the crop cover. This estimated soil erodibility factor will be given by this equation: K is equal to total soil loss divided by total erosivity index, okay, where EI is erosivity index. Okay, so in this way, you can calculate the erodibility of soil. So this erodibility K value varied from 0.03 to 0.69 under gravel and silt loam conditions, respectively in USA condition. For a silt loam soil at Dehradun, an average value of 0.30 tons per hectare per erosivity index was obtained. So this is erosivity and erodibility in the Usle equation. So next is the slope length and slope factor. The slope length factor is the ratio of soil loss from any length of slope to that to that from the slope length specified for a given soil erodibility value. Again, it is minus. Okay, so this slope length factor, this is the ratio of soil loss from any length of the slope of an area. Okay, the ratio of any length of the slope of the area to the slope length of 22 meters for a given soil erodibility value. And also you can calculate this LS value by this equation. LS is equal to LP divided by 100 under root LP divided by 100 in bracket 0.76 plus 0.53 S plus 0.076 S square, where the LP is the slope length and S is the percentage of slope. Now next is the conservation practice factor, that is the P. So this is the ratio of the soil loss for a given practice to that for up and down the slope farming. And here in this table, the conservation practices factor value are given here. So if the slope is 1.1 to 2%, then these are the value of the 0.60 if contouring is there, and if there is contouring and a strip cropping both measures, then 0.30. So similarly, other values are there for conservation practice factor. Next is crop management factor. So this is an important factor of SLEP because it accounts for the conditions that can be easily managed on soil to reduce the erosion. So this is the crop management factor. Now on the basis of this equation, there is one problem. Here, in an area subjected to soil erosion, the following information was available, rainfall erosivity index is 1200 meter tons per hectare, soil erodibility index is 0.20, crop factor is 0.60, conservation practice factor is 1, slope length factor is 0.1. So you have to calculate what will be the estimated annual soil loss. Okay. And after calculation, you have to explain how the soil loss will decrease by adopting some conservation practices like by contouring or strip cropping or mulching. Okay, how you can decrease the soil loss. Okay, so this is the solution of this equation. You know what is the formula for this usual equation? The formula is A is equal to RKLSCP. Okay, where R is rainfall erosivity index, okay, and all other parameters like rainfall erosivity index, K is soil erosivity index, crop factor, conservation practice factor, slope length factor means here LS both are there. Length is also and slope is also. So LS is equal to 0.1. Okay, so with that formula you can calculate the annual soil loss. So here RKLSCP. If you multiply all these things, then the answer is 14.4 tons per hectare per year. This is the annual soil loss. So if you want to reduce, this is in 1 year, how much soil loss is there? 14.4 tons. So how you can minimize these losses from that area? So you have to do some conservation practices on that area. So to reduce the soil loss, if conservation practices are introduced, okay. So suppose the after introducing the conservation practices, the value of P becomes 0.6. Okay. Earlier, this value was 1. Okay. Okay. Earlier it was 1, so now it is 0.6 because we have adopted some conservation practices on that area. So after introducing the conservation practices in that area, if you calculate the soil loss, then it will come 8.6 tons. Okay, so nearly 50% soil loss is reduced. 8.6 tons per hectare. In this way, you can use the Usle equation to calculate the soil loss from an area. Now, what are the use of this Usle? So, application of the universal soil loss equations are: first, it predicts the soil loss, how much soil loss will be there from any area, it can predict. It helps in identification and selection of agriculture practices. Okay, through some research, you can know that which type of agriculture practices is suitable for any area. Okay. And also, the third use of this display is it provides the recommendations on crop management practices to be used. Okay, so these are the use of this display. Now, the limitation of universal soil loss equation. So limitation of universal soil loss equations are first is the empirical because this is the empirical formula. Okay, so uh, the display is totally empirical equation. So mathematically, it does not illustrate the actual soil erosion process. Second is prediction of average annual soil loss. Its applicability is limited for estimation of only average annual soil loss of the given area. Okay, so this is a limited. Third is non-computation of gully erosion. So this equation is employed for assessing the sheet erosion and rill erosion, and it cannot be used for the prediction of gully erosion. Okay, so this is the disadvantage or limitation of this equation. The other limitations are non-computation of sediment deposition. So the equation estimates only soil loss but not the soil deposition. So it can't compute the soil deposition. So the deposition of sediment at the bottom of the channel is less than the total soil loss taking place from the entire water state. So this is all about the Huxley equation. Okay, so now we will see the wind erosion control measures. So there are three basic methods that can be used to control the wind erosion. First one is to maintain vegetative cover. The help of vegetative measures, we can control the wind erosion. Second is by roughening the soil surface by tillage practice. Third is conservation tillage, and fourth one is mechanical or structural measures. So these are the four measures which, with the help of these, you can control the wind erosion. First is the vegetative measures. So these vegetative measures can be used to roughen the whole surface and prevent any soil movement. Crop residue left on the soil surface protect the soil against wind erosion by increasing the surface roughness. Maintaining mixture of standing stalks and crop residue on the soil surface. This is the most effective practice to control the wind erosion. So wind erosion decreases in direct proportion with the amount of residue present on the soil surface. Residue reduce wind erosion by altering the wind velocity profile near the soil surface by absorbing the wind energy and thereby increasing the threshold wind velocity required to cause the soil erosion. So these are the vegetative measures to control the wind erosion. Now, with the help of a standing stocks or flat residue, you can control the wind erosion. But standing stocks are uh, most effective. or you can say standing stocks are at least 5 times more effective for controlling wind erosion than flat residue. So these standing stocks, this effectiveness of these standing stocks depend on the number of stems, density of stems, diameter of stems, etc. The slowly decomposing residue mulch cover enhances formation of a stable soil aggregates and accumulation of soil organic matter. The other measures are tillage practices. Now, next measure is tillage practices. So the tillage practice such as plowing are importantly adopted for controlling the wind erosion. So when you should start the tillage practice, so tillage practice should be carried out before the start of the wind erosion, and plowing before the rainfall helps in moisture conservation. So if on the soil more moisture is there, then that soil is less erodible. Hello, soil surface or when the soil type will produce sufficient clouds to protect the surface. So in this picture you can see the roughening the surface has been done to prevent the wind erosion. Conservation tillage, these are the other measures to control the wind erosion. So conservation tillage practice are important options to conserve soil water and produce abundant residues. No-till management is a conservation effective strategy to reduce the wind erosion because it leaves most of the residue and maintain an undisturbed soil surface. And also, it improves the soil water storage, and it will reduce the evaporation because in the soil surface mulches are there, so it will reduce the evaporation, and the moist soil are less susceptible to erosion. So this is one advantage of this conservation tillage. A combination of reduced tillage and crop residue management is an option in arid and semi-arid regions to reduce the wind erosion while maintaining the crop production. Now, those were the agronomical measures. Now, the mechanical measures. Some mechanical measures are adopted to control the wind erosion. So, under this mechanical measures, two types of measures are there. One is the wind break, and other one is shelter belt. Okay. So, this method consists of some mechanical obstacle. Okay, so some obstacle are created in the path of a strong velocity wind. Okay. So this obstacle will reduce the velocity of that wind, and if the velocity is reduced, then that soil erosion or wind erosion will be minimized. So this method consists of some mechanical obstacle constructed across the prevailing wind to reduce the impact of blowing wind on the soil surface. So generally in practice, two types of mechanical measures are adopted to control the wind erosion. First one is wind break, and second one is shelter belt. Okay. So first is a wind break. Here you can see these are the wind break. Wind break, yeah, wind barriers. Both are same. So wind break, this is a permanent vegetative measure which help in reduction of wind erosion. It is most effective vegetative measure used for controlling severe wind erosion. The term windbreak is defined as any type of barrier, either mechanical or vegetative, used for protecting the area like building, apartments, orchards, or farmstead, etc., from blowing winds. Okay. The windbreak act as a fencing wall around the affected area, normally constructed by one row or maximum up to two rows across the prevailing wind direction. Here in this picture, you can see this is a windbreak around the field. Now, similarly, the shelter belt is there, which are also used to control the wind erosion. Okay, so this is similar to the windbreak, but the difference is that the shelter belt is a longer barrier than the windbreak. Okay, and also it is installed by using more than two rows, usually at right angles to the direction of the prevailing wind. So that means across the direction of the prevailing wind. The row of belt can be developed by using the shrubs or trees. It is mainly used for the conservation of soil moisture and for the protection of field crops against severe wind erosion. A shelter belt is more effective for reducing the impact of wind movement than the windbreak. If you compare the shelter belt and windbreak, then you can say that shelter belt is more effective than the windbreak. And also, it will not only control the wind erosion, but apart from controlling wind erosion, it can provide the fuel, and also it will reduce the evaporation in that area, okay, and protect the orchard from hot wind and cold wind. Okay, so there are many advantages of this shelter belt. Here you can see this is the shelter belt. Now, so actually these are the good things to control the wind erosion, but there are some constraints of this vegetative barrier. Okay. What are those constraints? First is lack of tree or shrub material. Okay. Nowadays, every day the trees are cutting, so obviously there will be lack of tree or shrub materials. So from where you will take these materials for constructing the vegetative barriers. So this is a limitation. This is a constraint of this vegetative barriers. Second is lack of management guidelines. Third is absence of technical support, training, and fund. Okay. These are the constraints. High cost of establishment of this type of vegetative barriers. Invasion of insect and pest. If you are creating the vegetative barriers, then obviously there will be a lot of insect and pest will attracted, and it will attack on the crop. The other constraint of these vegetative barriers are attraction of birds, because when tree will be there, then birds will be there. So attraction of birds which consume grain and reduce the yield. The next is competition of barriers with crop for light, water, and nutrient. Okay. The other one is difficulties in protection against grazing by livestock. Okay. So these are the some constraints of these vegetative barriers. So these are the some control measures, uh, mm, vegetative measures, tillage practices, conservation tillage, and mechanical measures. Okay. Under the mechanical measures, the windbreak and shelter belts are there to control the wind erosion. Series of this lecture, there is some quiz. Let us see these questions. First, death is also known as raindrop erosion because it is caused by the impact of raindrops on exposed soil surface. So, which type of erosion is caused by the impact of raindrops? So, this is the first type. That is the splash erosion. Okay. The second question is the uniform removal of soil in the form of thin layer or in sheet form by the flowing water from a given width of sloping land is called. In which type of erosion there is soil and water will flow along the thin layer. So the correct uh, answer is sheet erosion. Okay, in the sheet erosion, the soil mixture of soil and water flow in the form of thin layer. The third is erosion is formed in the cultivated field where the land surface is almost irregular. So this is the next stage of this sheet erosion. So this is known as the real erosion. So in the real erosion, this is formed in the generally in the cultivated field where the land surface is almost irregular. Okay, so when reels are formed in the field, then you have to do tillage operation. Otherwise, if you don't do tillage operation in the field, then this will uh, will become the gully erosion. And if the gully will form in the field, then this is very dangerous. So more soil will be lost in the gully erosion, and you can't do cultivation practices in that type of field. Uh, it is the advanced stage of real erosion. Which type of erosion is known as the advanced stage of real erosion? So answer is mm, gully erosion. Gully erosion is the advanced stage of real erosion. When reels get larger in size and shape due to prolonged occurrence of a flow through them and cannot be removed by tillage operation, these are called gully. Okay. If reels are formed in the field, you don't if the tillage operation is not performed in that field after the reels are formed, then that reels will become large and it will form in the shape of gully. So large gully and their network are called in one term, which is known as the ravine,
Yes.
RAVIN.
Yes, sir.
The other question is removal of
Erosion.
a stream bank soil by water either flowing over the side of the stream or storing from there is called. क्या होगा इसमें? This is the stream
Seashore.
bank.
Seashore.
A stream seashore generally happens in uh, coastal area. This is the stream bank erosion.
Stream bank. Okay, okay.